Today we'll derive the electric potential of a thin disk. So remember that the differential electric potential was equal to 1 over 4 pi by the permittivity of free space by the differential charge on the radial distance to the point where we're finding the charge, which in this case would be along the axes of the disk. So in this case, the differential charge is going to be the areal charge density multiplied by the area of this thin ring, which is going to be 2 pi r dr, where dr is the infinitesimal thickness of this ring. So just imagine this ring being rolled out in a rectangle of length 2 pi r, and multiplied by dr, the thickness, gives the area. And by Pythagoras, r is equal to the square root of r squared plus z squared. So you can see that in this case, r is going to be variable. So now we can rewrite the differential potential as 1 over 4 pi epsilon naught by sigma by 2 pi r dr over the square root of r squared plus z squared. And if we integrate both sides, we get the total potential at this point. Now let's take the constants outside the integral. So we have sigma by 2 pi on 4 pi epsilon naught, and that's multiplied by the integral of r on root r squared plus z squared with respect to r. And what we do is sum the potentials due to each of these rings from r equals 0 to the radius of the disk. So that's really what we're doing when evaluating this integral. And we can simplify this by cancelling pi, and 2 on 4 is 2 in the denominator. Now using u substitution, we can evaluate this integral. So we let u equals r squared plus z squared, and therefore du is equal to 2r dr. And now we can write this integral as du on 2, and that's over the square root of u, or u to the 1/2. So this is the same thing as u to the minus 1/2 du. So evaluating this integral, we get u to the 1/2 on 1/2, which is 2u to the 1/2. And that's multiplied by 1/2 outside this integral. So the 2's cancel, and we end up with u to the 1/2. So therefore, we have sigma on 2 epsilon naught, and evaluating this integral, we had u to the 1/2, which is root r squared plus z squared. And we evaluate this from 0 to the radius of the disk. So what we get is sigma on 2 epsilon naught, and that's multiplied by the square root of the radius of the disk squared plus z squared, and then minus the square root of z squared, which is z. And this here is the total potential at a point along the axis of the disk at a distance z from its center. And I'll see you in the next video.